Hey guys, what's up? So today we're actually going to be looking at January 2019 paper 2 number 9. And guys, in general, number 9 is usually circle theorem and bearings, right? So very important to note that. And this is a pretty easy question, guys, if you know the rules. I'm just letting you guys know straight up and straightforward. If you do not know the rules for circle theorem, you're not going to get the questions correct. It's not one of those topics where you can just work it out and guess it out. You can't guess it. You're gonna have to learn the 7 rules. And the 7 rules are on my YouTube channel. I'm gonna also put a link to the 7 rules, but you need to know the rules before you can do these questions. All right. So let's get going, guys. Let's get going. Let's get going. So it says here the diagram below, not drawn to scale, shows a circle and the points P, Q, R, T, and V are on the circumference. QRS QRS is a straight line, and angle PVR is 75 degrees, and angle TRS is 60 degrees. Right? So, guys, this is really simple. It says determine the value of each of the following angles. Show detailed working where necessary. So, we need to find P to T to R. So, guys, the angle is always where So the angle is right here. The angle is always where the middle letter is. So if we were to mark the angle, then the angle would be right here. Right here. This is the angle that I'm asking for. So this is pretty easy. And the next angle that I asked for is TPQ. So I'm just gonna put that right here. Just gonna put that right here. Angle TPQ. Right? So pretty simple. All right. So how do we find PTR now? Which is that angle up there where the T is. How do we find? So let me just kind of show you how it goes. So it's P to T to R, and then we need to find this angle here. So guys, there's a rule, right? And that rule is actually rule number 3, I think, out of all the rules, and it says angles on the same arc are equal. And guys, if you look carefully, let's rub this all out. If you look carefully, guys, these two angles, this angle here, this 75 degrees here, so is supposed to match this 75 degrees here because they're on the same arc, right? So this is the arc that they're on. So this means that here is also supposed to be 75 as well. Cool. So this is one of the rules, guys. So we're going to say P. We're going to say therefore PTP, well, PTR is equal to 75 degrees. All right. So, okay, so we found PTR, guys, is 25 because they're on the same arc. So angles on the same arc are equal. So that's it. So we can move on now to the next part. And the next part says we need to find T, P, Q. So TPQ is the angle right here. This angle right here. And that's not hard to find, guys. Why is it not hard to find? Let me show you guys something interesting now. I think this is rule number 4. So angles in a cyclic quadrilateral add up to each side add up to 180, and it should add up to 360 overall. So that's the rule, guys. Angles in a cyclic quadrilateral. So if you look here, guys, this is one side of the quadrilateral. This is the second side. This is the third, and this is the fourth, right? And we'll have a straight line right here, guys. So we can easily show if here is 60, guys, then right here is supposed to be 120. So let me just draw that right here. So if right here is 120, guys, then that means the angle here, let's call it X. Now let's call it A. The angle here at A, if you add, so this one now is angles in a quadrilateral, well, it's cyclic quadrilateral, add up to 180. Make sure I spell that right. All right. So yeah, guys, it's supposed to add up to 180, right? Okay. So, so guys, what we're supposed to end up getting is 120 plus A is equal to 180. And if we work that out, guys, then A is going to end up being A is going to be equal to 60 degrees. So that's the angle that's the answer for that one. So for PTR is feet for PTR the angle is 75, but for TPQ the angle is 60 degrees because A plus 120 here is supposed to give us 180, right? So that's the answer for that one. All right. Cool, cool, cool. All right, so we should be okay now. Let's see what the last part of the question says. It says here, obtuse angle POR where O is the center of the circle. All right, sorry. It says obtuse angle POR where O is the center of the circle. All right, so let's go back and look at the circle again. And I'm going to clear the other solutions, guys, just for the meantime. Okay, so guys, we need to put a spot in the middle because I'm not really seeing an O. So let's assume that that is the middle of the circle. All right, and you're gonna have this. You're gonna have this. And then you're gonna have an angle here in the middle, right? Yep, yep. All right. Okay, cool. So, all right, guys. So, guys, when we're working this one out now, guys, it's kind of simple. So, guys, remember the rule. It's actually rule number one that says angles at the center are twice the angle at the circumference. So the obtuse angle PO to R, well, POR, where's R? Yep. So the rule we need for this one, guys, is we need to say angles at the center are twice the angle at the circumference. All right. So this is the rule we need for this one. So guys, here is 75. But if up here is 75 and up here is 75, guys, and in here should be 150. So the angle in here should be 150, right? Let me kind of carry that down. Cool. So this should be 150, right? And the reason why, guys, is because these are on the same arc as the 75. If you look here, this is the arc here, and 75 is here, and 75 is also here. All right, guys. So that pretty much finishes the circle theorem now, guys. The answer is, so POR, let me just put that here, POR is equal to 150. All right, guys, and that's pretty much it. We're good to go. And that's all of the circuit theorem. Guys, remember circuit theorem is a topic where you're not going to understand this topic unless you know the rules. There are 7 rules. I have them on my YouTube channel and I'm going to share a video. Please learn the 7 rules first and then you can try these questions. All right. All right, so let's go down to the variance section. Usually this is a variance question or a trigonometry style question. Well, let's do this together now. So it says a person at the top of a lighthouse, right? TB sees 2 ships, ship 1 and ship 2, approaching the coast as illustrated below. The angle of depression are 12 and 20 respectively. The ships are 110 meters apart. Complete the diagram by inserting the angles of depression and distance between the 2 ships. Alright, so that's easy. That's pretty easy. Let me just put 20 here. So 20 is right here. 12 is a smaller angle, so 12 should be right here. Alright. And then this angle now is going to end up being 160 because it's on a straight line. And the distance, they said was 110. So right here, this is going to be 110 meters. And that distance is, show you guys where the distance is. Distance is from here to here. So that's where the distance is from. So this is what you need to do just to get the 1 mark. And it says the distance TS between the top of the light board and ship 2. Okay, so all right. So what do we need to do that now? How are we going to solve that now? What do we need to do to solve that part in order to get the distance, right? Well, guys, we actually need to use the sine rule to solve this question. And before I get started, I'm just going to remind you guys, the sine rule is pretty easy to remember. It's always in the formula sheet. That's why it's so easy to remember. So if you don't remember it by heart, that's fine. And let me just type the sine rule over here. All right, so the sine rule, guys, is A over sine A is equal to B over sine B. Cool. So this is the sine rule. This is what we need to use today, right? Now, we don't necessarily, yeah, we need to use this rule, but let's just work it out, right? So we're going to give ourselves some space and time to work this out. Okay, so remember we're using sine, guys, which is pretty much opposite over hypotenuse, right? Right, so we're going to say 110, which is the side for A, and then we're going to say sine, right, sine 8 over sine 8. Sine 8, which is the angle up here, the small angle up here. Here is sine 8. The 8 is that angle up here. So 110 over sine 8 is equal to the side we're trying to find, the hypotenuse. We need to find the hypotenuse, guys. So we're going to say that this is equal to the side we're trying to find, let's call it S2, capital S, and then put 2, over sine 160. All right. So we're going to end up getting, right, so we're going to end up getting S2, put a capital S2. S2 is equal to 110 divided by sine 8 multiplied by sine 160, and this is going to give us right? It's gonna give us 270 meters, right? Yep, 270 meters. So that's the answer. Right, so that's the answer for S2, right? The side, it asks for the side TS. So here, let me just draw it. Here to here is 270 meters. Cool. Nice. And then, okay, so it says the next thing we need to find now is the height of the lighthouse. That's the next thing we need to find. So the height should be really easy to find now, guys. They're asking us next, guys, for the height, which is over here, right? This side right here. But it's easy to find the height, guys, because remember, the sine rule says opposite over hypotenuse. Sine the angle is equal to opposite over hypotenuse. So this is really easy to solve now. Not as hard as the last one to solve. So we're just gonna say sine 12 is equal to opposite over hypotenuse. So O is the side we don't know. That's the side we need to find, right? Which is the TB. Let's call it TB though. That's the opposite side. And I'm gonna put that over um, 270. Yep. All right. So we're gonna get TB is equal to sine 12 times 270. All right. So TB is equal to sine 12 times 270. Cool. And then TB is going to be equal to TB is going to be equal to 56 meters. Right? All right. So we're good to go. We're good to go. And that's all we needed to know, guys. So this, let me just rub it out then. No, let me put it on the inside. This side, right in here, from here to here, is 56 meters. So this question wasn't too bad. It was like a trigonometry question. Sine rule was included. Not too much bearings, more of a trick question with the sine rule. But still, I would still consider it close to bearings because they had to use the sine rule for the first part. So anytime you get this question, guys, it's either you're gonna need to use either the sine rule or the cosine rule, right? So prepare yourself for this question after circuit theorem to get a sine rule or cosine rule question with it. Cool. All right, guys. So stay safe and God bless. Remember to do your best, and God will do the rest. And I'll see you guys soon. All right.